Okay, so ladies and gentlemen, good day. Today we are going to look at t-statistic. The idea of t-statistic was actually introduced by a scientist called William Selly Gossel in the year 1908, and the work was published in the video. And the t-statistic is actually trying to show how the differences between the mean of two groups and how they are related. So we use t-tests to show the differences or to show if there's a significant difference between the mean of two groups and how they are related. So whenever we have a mean from two different groups, so you use t-tests to compare them to see if there is a significant difference between the two groups. And usually, a t-statistic is a method of testing hypothesis. We remember we have alternative hypothesis and we have null hypothesis. So null hypothesis, we always consider that there is no statistical significant difference between the two groups. But when you run a t-test, the t-test will tell you whether there is a mean difference or there is a significant difference between the two mean. But your null hypothesis will always be there is no significant difference between the two groups. And usually we use usually there are some conditions that must be maintained before you apply a t-test on a particular data. Number one, the sample must be randomly selected. First, the sample must be randomly selected. And the sample drawn from a population must be normally distributed, And that is two. Yeah, that is two. Okay, I think three. One, the group must actually be two. There must be two groups before you apply t-statistic. And second, the data must be normally distributed. That is when you collect a sample from a particular population. So the population must be normally distributed. And then after that, there must be no standard deviation. There must be no variance. There must be no variance before you apply the statistic, because if there is a variance, it means there is no need for any t-test. And the mean is usually compared between two groups. So these are the kinds of actually criteria that you have to consider when you have a data. One, the data must be between two groups. And the sample you collected from the population, the data from the population must be normally distributed. And the standard deviation of the sample must be unknown. So that is for the t-test. So we are trying to always compare the mean between two groups. And then we have different types of t-tests. We have paired t-tests, we have independent t-tests, and we have one sample t-test. So in the case of paired t-tests, you are just trying to compare the mean within a group between 2 points in time. Like for example, maybe you have the same group, you have a group or you have your sample. Then now, after you collected your sample, then maybe you want to check the effect of anti-malarial drugs in the group. So maybe first, before the treatment, you take the body weights. And after the treatment, you take the body weight. Then you take the mean of the body weight before the treatment and after the treatment from the same group. The body weight, you take the mean of a body weight before the treatment and after the treatment, and you compare them. So in a paired t-test is the same group. You check the differences. You check if there is a significant difference within the group before and after the treatment. And in the case of independent t-tests, you are talking about two different groups. Like for example, now you want to check the performance of university students in terms of their statistical performance, that is in terms of understanding statistics. So assuming now you collected sample from ABU and you collected sample from BUK, and now after you collected the sample, then you take the average mark from ABU and you take the average marks from BUK and you compare them. So in the case of independent t-test, we are talking about the mean, or you are trying to compare the mean between two different groups, two independent groups. And then in the case of one sample t-test, we are comparing a mean of a particular sample with a standard value, Let's say now, assuming now the average milk provided by a particular company is 20. Now, a researcher now went to that company and he now collected the milk from that particular company in 5 different days. And after he finished the collection, he took them in. So based on that, he now compared the mean he obtained from the company and that of the standard value and make a comparison between them. So that is in the case of one sample t-test. Yes, and I'm going to stop here for this.